Hello everyone. Last time we learned that ownership is strict. Once you pass a value, you lose it. But wait, how do we actually use a value in multiple places without constantly giving it away? That's where borrowing comes in. It's like lending your friend a book, but you still own it. They just get to read it. And once they are done, you still have your book. Let's understand what is borrowing. Borrowing means temporarily giving access to a value without transferring ownership. Rust does this with references. But in this case as well, there are some rules enforced. Rule number one, you can have any number of immutable references, and if you need mutable reference, you can only have one at a time. And rule number two, references must always be valid. By valid reference means that you can't use reference to an invalid variable or a value gone out of scope. This rule is vital to tackle dangling pointers often faced in C and C++. Now let's see in code how we can use borrowing. We have created a calculate length function to calculate the length of a string passed to it as a parameter. To calculate the length, we don't need to change the string value. So we will borrow the value from main function by using ampersand string as reference to the string value. In the previous video on ownership, we saw that after passing the value in the function, we couldn't use it anymore until we take the ownership back from that function. In this case, we are returning the length as an integer, but still it works fine while printing. This is because we didn't transfer the ownership. Main function still owns the value. Rather, calculate length just borrowed the value using reference. As per rule number 1, we can borrow immutable references as many times we want. Here, we have references R1 and R2 for the same string S. They both print fine. Let's see what happens if we make one of the references mutable. To make a reference mutable, the original string has to be mutable as well. Now running the program, it shows that cannot borrow S as mutable because it is also borrowed as immutable. You can also see in the error in which lines the error is occurring. This happens because the program violates rule number 1, which states that there can only be one mutable reference at a time and no other references. One quick note you can remember here, that even if we have a reference but not using that later anywhere in the code, the compiler will not throw any error since the reference is never used. That's why even though we have R1 declared, but since it is never used, we are still not getting any error. This happens probably because there is a trick to use multiple references. It is possible to create a reference in a scope. Once the scope ends, the reference pointer also gets destroyed. So after that, a mutable reference can be created. Here R1 within the scope already mutated the value of S. So after R2 mutates it again, both the changes persist. Let's see another example. This function has a return type of ampersand string, which means it returns a reference to a string value. Inside the function, we created a new string named S with the value rust. At the end of the function, we are trying to return a reference to this string. At first glance, this might seem valid. However, it's not. Here's why. The string S is created within the scope of the function. So its ownership is tied to the function's local scope. When the function ends, S is dropped, which means its memory is deallocated. But instead of returning the actual string, which is transferring ownership, we are returning a borrowed reference to it. This reference would then live outside the function, but the data it points to, which is S, no longer exists. This would result in a dangling reference, which Rust strictly forbids. This is a classic example of the violation of Rust's borrowing rules. References must always point to a valid data. Therefore, this function is not valid and will result in a compile time error. Borrowing is the safe middle ground between strict ownership and free for all references. You can use ampersand for read-only access, and if you want to use mutable, use ampersand mute for exclusive write access. These borrowing rules guarantee that you never end up with unsafe or invalid references. This is a unique and arguably one of the most confusing aspect of Rust programming language. Even highly experienced programmers make mistakes in this. I would highly recommend you to practice this a lot before building any project in Rust. So that's all for this video. We'll catch you in the next one.